So now look at our local behavior around a zero. There are two aspects of polynomials we need to consider to understand how the graphs behave. End behavior, which we looked at, and now we look at local behavior around the zeros. Okay, so the multiplicity of a zero determines the behavior around that zero, what's known as local behavior. And it ties to the look of the power function y equals x to the n. So what does that mean? So suppose we have the following. Multiplicity, 0, and let's say that we have the following 0. We have a 0 of 2, multiplicity 2. We have a 0 of 3, multiplicity 1. 0 of -2, multiplicity 3. So when we look at the graph, again, I'm going to mark these zeros. So I have 2, -2. So we have 3, 2, -2. Okay, so around the zeros, as we get really close to 0, all of a sudden the graph around that 0 will look like its power function. So for example, if we have multiplicity 2, the 0 of 2, multiplicity 2, that means that right around this 0, what I have is the following. So that looks like a quadratic. It's also maybe facing up, I don't know, but it's going to look like a little parabola. All of a sudden, right around that 0. What about the 2? I look at the 2. Oh, so no, that was the, sorry, the 2 was that. All right. What about the -2 here? It's a multiplicity 3. So what's going to happen here? Well, it's going to look like this S-shaped right around the 0. Sometimes you won't, if you look at a graph, you might not be able to tell, but it will behave just like this if you focus long enough. What about, there was another 0 at 3 right here. And this is a multiplicity 1. So then that's just going to be, so multiplicity 1, that's a straight line. So it's just going to go right through the 0 or the x-intercept, and it's going to look like a little straight line. So the multiplicity determines the local behavior around that point. So either it's going to be like a parabolic looking or cubic looking or straight line. So for example, what is the behavior around the zeros for the polynomial y equals -2 times x plus 4 to the third times x minus 2 to the second times x plus 3. So again, what I'm recognizing again is the zeros and their multiplicities. So what I have here is, again, if I make this a -4, this whole factor turns 0, which means everything else will now be 0 times anything is 0. So I have a 0 of -4, and then to look at the power, and that's a multiplicity 3. I have, if I make this variable 2, this particular factor will turn to 0. 2 minus 2 is 0. So that's a 0, 2. And it's a multiplicity 2 because the power here is a 2. Finally, I have, if I make this x here -3, -3 plus 3 is 0, but this is to the first power, so this is a multiplicity 1. Okay, so to determine the multiplicities, we sort of have, well, we do, we need to have it in factored form. But that is all that happens. Right around the behavior, we look at the multiplicity and determine how it's going to behave around that zero.